All right, then it's 1 o'clock here in Michigan. Hello, everyone. Thanks for coming on today. My name is David Johnson. I'm an antioxidant scientist at CalSec, and I'll be moderating this webinar Wednesday. This is the fifth installment, actually, of Webinar Wednesday, but it's the first for lipid oxidation and quality. So we're really excited that Rick Della Porta can donate his time and give us this seminar today. Rick has worked at PepsiCo for the last 34 years, and he's a leading expert in analysis of fats and oils, particularly frying oils. I got to know Rick personally about 2 years ago. He helped judge the student poster competition, and he's been a very active member of AOCS for the last 25 years. So we're definitely really fortunate to have him on today. He's going to give a talk today about antioxidant testing and application review. One reminder that I would like to stress today is that everyone's going to be muted throughout the whole talk. And if you have any questions on this little GoToMeeting thing, there's a chat option. So if you have a question, you can write it in the chat. And then once Rick finishes his presentation, I'll read that chat. And any questions you have there, I'll ask Rick afterward his presentation. So Rick, the floor is yours. And thanks again for coming on today.
Thank you, David. Good afternoon, good morning, good evening to everyone out there. I appreciate the opportunity to do this little webinar. It's, for those of you who are at the AOCS annual meeting, this is basically the same presentation, a few modifications, a little expansion. And so I appreciate you all being interested. And thank you to the AOCS for inviting me. So like David said, I've been around for a while. My background is not food. It is strict analytical organic chemistry. I got a locked-in job at Frito Lay back in 1984 and was able to apply my non-food background into the food and fats and oils in particular. So I've done a lot within Frito in those years. I'm now nominally their global oil technical expert. And I spend a lot of time these days doing antioxidant research. Some of the facts. I hate boring people with this, but this is kind of a boilerplate slide. Right? We've all seen Carfridge's little drawing there, and we've all used it at one of our presentations. But it does point out one key area, which is the free radicals. And these are where antioxidants come into play. Obviously, they are a preventive intermediate to allow oil to go through processing, whether it's frying, baking, or even just sitting on the surface of a cracker or a chip, and keep it from oxidizing. We find that natural antioxidants can give us more antioxidant activity in thermal situations than synthetic ones. But along the way, one of the reasons I put this presentation together was I rely a lot on research outside of what I do. Basic research coming from academics, government, and even industry partners who publish, make it easier for me sometimes to make decisions. The big opportunity I have is to improve the oil quality, and using antioxidants is highly beneficial, especially the natural ones. They allow us to use the healthier polyunsaturated oils and then extend our fry life. And of course, for us, it's all about product shelf life. But what I found as I listened to papers, presentations, read papers, is that there's a big disconnect between what goes on in research and the actual applications that we need for these antioxidant systems. Years and years ago, I remember Charlotte Jacobson saying the same thing. There's no consistent antioxidant experimental protocols. Everybody just kind of does what they feel demonstrates an application, but it's not always useful in the real world. I did just a quick comparison in the academic world. There are various and sundry test protocols. They focus on data and results more than the application. And a lot of the test systems are idealized to demonstrate data. It doesn't actually translate to real world results in most cases. In the real world, we fry two basic ways. Either a bulk batch frying system, could be a restaurant, it could be my kettle system, or it's continuous, where there's always product going in and always oil coming out and always oil going in, and we reach an equilibrium state. For the real world, the focus is twofold. It's either right away we're going to eat it, restaurants, or it's going to sit on that shelf for anywhere from a week to 6 months, depending on the product. And lots of things get fried. Simple things, potato chips, complex things like battered, dipped cheese sticks, chicken parts, anything you can throw in a fryer. I was at the state fair. Dip a Twinkie, fry it. Fill a pocket full of beer and fry it. Those are immediate consumption things. They're not going to sit around very long. There's a big difference in the interpretation of a stabilized oil and the need to stabilize it. If I'm stabilizing a fresh oil that's going to sit in a bottle or sit in a silo, lots of ways to do that. If I'm going to stabilize something in a fryer, that's going to require some more advanced information. The challenge becomes, how do we get academic discoveries to cross over to commercial need? How do we relate the activity measurements to the stability while frying and then after frying? And how about these measures? What's standardized? We have lots of options for antioxidants, but the measures for them don't always match up to what they actually do. So kind of a short, it's not an all-encompassing list, but the basic synthetics that we've always used: tertiary butyl hydroquinone, related hydroxyanisole, related hydroxytoluene, even ascorbyl palmitate. Crisscrossing combinations. I mean, I've got systems out there running mixtures of TBHQ into tocopherol or TBHQ and some rosemary. Oryzanol's got an interesting antioxidant denotation. Green tea extract out there, oregano, some new stuff that's come out these days. And of course, the ascorbic acid or acerola, depending if you want an all-natural material. We combine this stuff for effect. Some have immediate effect in the fryer, some have extended effect outside the fryer. We also have to find ways to measure things. The standard measures of peroxide, free fatty acid, they give you an insight into what the quality of the oil is. And there's a big range of what these numbers mean in a certain industry. I tell you for a fact, I drive my suppliers crazy because my numbers for peroxide and free fatty acid are an order of magnitude lower than what the restaurant people can survive with. HPLC analysis, great way to take the oil apart. Look at the components, the concentrations. Takes time. You have to understand the relationships that go on with the oil from fresh to fry, post-fry. Ways to measure stability, there's all sorts of fun ways. I've actually started working with the Rapid Oxy. It's a neat little pressurized oxygen device from Anton Par. A whole lot easier to set up than an oxypress. But OSI and Ransmat are standards in the industry. They all tell you something about the relative stability of an oil that's being forced under heat and oxygen and how long it might last. Does not always translate to finished product. The antioxidant testing, test for capacity, free radical with ORAC, PrAP, DPPH, looking at total phenolics. I'm sure there's several others that are out there that I haven't played with yet. A lot of industry like to look at total polar components, which is really good in certain areas where everything changes the same way. I'm talking about mostly batch frying, where you're at a basic input of a material and a very slow refresh rate. So you get to see things and they tend to correlate. And then looking at deeper into the oil, what about the secondary oxidation reactions, those stable carbonyls, maybe ketones that are left behind after that first phase oxidation takes place. The paranicidine test, T-bars, my apologies to Dr. Franklin, the Crease test, total carbonyl value, even a ferric chloride analysis. They all impart some information. It's how they relate back to that overall oil and then finished product quality that becomes critical. And then when we test for shelf life, the old shell oven, of course, sensory is the best way to get an answer if you want to know what the consumer thinks of your product over time. GC Headspace gives you a lot of information. It takes a good GC mass spec analyst to decipher where do those peaks come from, what's driving them, how do they relate back to the oil quality. And of course, sometimes we can't wait 6 months for a result, so there's accelerated shelf life techniques, putting product in heated ovens, measuring it against time, against real shelf life. These are the things that, and the methods that are available and are used, but again, there's no documented, consistent, total methodology, I guess I want to say, for comparing that to an antioxidant response. In the industry, we can't do a lot of these tests. They take too long. We have to have correlated methodologies. The FT mid and near IR devices, correlated to DSC, to EPR, NMR, and electropotential. In order to make these valuable and usable, they require very specific and repeatable protocols that can then be translated to a product response. We spent a lot of years figuring out how we could get our plant systems to use rapid technology, secondary analysis that correlated to the product quality that was coming out of our fryer. And it works, obviously. We've done a great job, and I'm still employed because of it. Some examples of things. Studies with batch fryers go the full range. Bread cubes, potato cubes, frozen French fries, sliced potatoes. You know, anything you can fry, throw it in the fryer and see what it does to that oil. But how often? How long? How many samples? You know, a batch every 30 minutes or one batch every hour for 8 hours. Repeat daily for 5 days. How many total batches? What's the oil makeup? Sometimes no makeup. And as you, again, reduce the volume of oil, you concentrate the components that build up. It's significant data, but it doesn't relate to what happens in the real world. Closely to restaurants, and granted, they do need help sometimes keeping that oil quality. But in immediate consumption environments, the customer, sometimes they can tell, but usually not, doesn't matter to them as much as when we go to the consumer that's buying bagged product off the shelf or out of our freezer, and then keeping it for days or weeks before they use it. Continuous fryers are tough to simulate, not really practical in the lab environment. One way that I found is to scale a batch frying to a continuous system, where I match up the dwell times, my surface area to total oil volume, my weight to oil inputs, and then my replenishment rate. For me, this has been a great way to generate near real world application data. I don't generate a lot of free fatty acid data. I can't generate a lot of polymer data. It's just not a long enough scenario in a normal workday to do that. But it does generate oxidation data, and it gives me a manageable, repeatable way to study the effects of different antioxidants on the oil quality, and then take the finished products that I make and run them through accelerated shelf life to see if, even though I don't see a change in the stability of the frying oil with an antioxidant, did it do something to the finished product that just didn't do anything to the immediate stability of the oil. So I look at activity studies, studies with just the antioxidant in the oil. Not all antioxidants react to the OSI. Many show pro-oxidants. I say coprals. But it's a false result sometimes. The coprals really don't increase the overall forced stability of an oil. But that product comes out and it has stability increases that were unexpected in terms of shelf stability under a rapid aging situation. I haven't discounted things just because they don't show an OSI response. I will actually take the products that I make and put them through Accelerated to see if there's a difference at different levels. I've yet to find tocopherols actually causing my product to go bad faster, even at high dose concentrations, 3, 4, 5,000 parts per million in the oil. Activity methods, right? I've been using the DTPH method. It's good if you maintain control of it. ORAC, we have an ORAC device. I've been correlating that. But it's usually focused, in most of the methodology I read, is focused on one antioxidant being tested against that measure. Most of the antioxidant systems are mixed. And you also forget that you're putting rosemary and ascorbic acid into an oil that already has tocopherol. So you need to baseline the oil against what the tocopherols alone are doing. And I've had a lot of interesting results when I vary the ratio of rosemary and tocopherol and TBHQ with these methods and try and compare them to the prior versus the fresh oils with and without. Same thing when I look at finished product. They don't always follow. The shelf life and the volatiles don't always follow with the antioxidant additions. Sometimes very high additions of certain antioxidants create volatiles that mislead my GC, even though the consumer and our expert panels don't taste the difference. And you've got to watch out for that base flavor. If you put too much rosemary or oregano, you're going to taste it. And that's fine if you're doing a product that's got seasoning and all additional flavors, that's fine. But when you're talking about something as mildly flavored as a potato chip, you have to be real careful about how much of these components you add. They will add flavor, and at certain levels, they will change the color a little bit too. And of course, when it comes to the regulatory side, that's another battle in some countries. Certain extracts are fine. You can use rosemary as a flavor. Don't call it an antioxidant. You can't use it that way. It has to go through a separate approval in those countries for use as an antioxidant additive. There are also addition limits. Some countries limit how much additional tocopherol can be added, how much total rosemary as measured by carnoxolic acid can be added. There are different forms I've found. One country says I can't use ascorbic, but I can use ascorbic palmitate. So I have to go back and reformulate and test if I'm getting the same response with ascorbic palmitate as with ascorbic acid. And some of these approvals take months, which isn't bad, or years. It's really country dependent. There's a lot of legal wrangling that goes on, documentation that goes on. We try and get the vendors to join us in this process because it's going to benefit them in the long run. So I have a few recommendations. Again, let's set a standard. I track everything against 200 ppm TBHQ. It just is a baseline I benchmark against. It doesn't give me a yay nay, it just gives me a benchmark. And then we use Trolox as a baseline for our activity measures with the ORAC. It gives, again, it's a benchmark point. I can say better or worse from that activity standpoint. So background conditions are critical. Know your audience. If you're looking to get into a restaurant, that's a whole different pattern than getting into a commercial. Talk to the businesses you want to work in. Continuous frying is how we make a lot of product, and it's a turnover effect. So we never actually use up the material that goes in. We just reach an equilibrium state, and that gives us the benchmarks that we use for product testing. Be aware of fryer temperatures. Some frying is done at low temperature, 325. Others are done well over 400 degrees. Some antioxidants and materials don't like getting that hot. So you have to be aware of what happens to them when they get hotter. And then again, what are you frying? Potatoes are not the same as bread cubes or chicken when it comes to a fryer. I really, really stress about results. Don't generalize. Be very specific about what you've tested, what your expectations are, and how it might be applied. I think that's pretty much all. A little bit of a personal, wish list for me. Speeds up my work, but at this point, I think, yeah, I'd like to thank the AOCS and LOQ for inviting me, my whole PepsiCo support team, and if anyone's got questions, I'm sure David is ready to field them.
Yes, please ask questions in the chat box, and thanks a lot, Rick, for your great presentation. I got a couple questions, and I can start it off as people would like to write some questions in the chat box. Rick, are there any pilot scale continuous fryers? And if there are, do they translate?
There are. There's several companies that do this. We have our own as well. They do translate fairly well if you can get enough runtime on them.
Mm-hmm.
Again, it's turnover rate in the fryer, conditions of the fryer environment, temperature, and there's always a cost associated with that.
Yep.
Moving down to even to a smaller, and I'm talking like we have a 1/10 size fryer setup pilot. Go smaller than that, there is an issue, and we've experienced this here, where the volume of oil is a lot more than a regular size fryer because of the heat requirement to get it hot, keep it to the temperature. So we had some very misleading results in our processing lab with our little, what we call our 30-pound fryer.
Yeah.
Because the volume of oil was 3 times higher by ratio than a real fryer in order to heat it properly.
So that volume is really important then, huh?
The volume is really important because our turnover was 3 times longer. The dilution effect was greater. So we thought we were seeing some nice positive results that when we went to the plant, didn't translate. And that's when we discovered there were some volumetric effects.
It's interesting. Thanks, Rick, for that answer. We got a question from Nisa. She's asking, let's see, I just lost it. Have you ever tested a frying oil antioxidant and actually seen the oil fry life extended?
That's a yes.
I guess to follow up with that, when you guys are focusing on it at PepsiCo, are you focusing on extending the fry life? Obviously, you're looking at extending the shelf life of the chip or product as well, but are you guys also looking to extend the fry life?
Well, what by definition, I guess, is fry life? To me, in the fryer, we don't have a lifetime. It's always there. We're always putting fresh oil in, so it reaches an equilibrium state. We don't have a fry life endpoint. What we try and do, and the goal of our research has been to match the oil quality in terms of the oil stability and oxidation and free fatty acid in the fryer to a control, palmoline or hyaluronic sun.
Okay.
And so then that translates to we have to have a finished product that matches the shelf life of that oil with our antioxidant in an oil like traditional sun, soy, rapeseed. So that's how we benchmark. We benchmark against an existing shelf life and oil combination, and we have to match that in order to be successful.
Yeah, I think that's a really good point. I think you brought that up earlier with the 200 ppm TBHQ, that it's really important to benchmark these things, especially in really complicated reactions and interactions like frying is. So thanks a lot for that answer. We have another one. Jennifer's son is asking, can you talk more about how to use FTIR and HPLC in this type of testing?
Well, I mean, they're separate entities. HPLC is primary. So if you pick a parameter that you're measuring and you get a range of samples that the HPLC says have different values, you can then translate that to an FTIR system. and there's plenty of them out there. You have to have a statistical data set and analyze it and use the statistical analysis packages to correlate to the HPLC parameter. Say you're looking at tocopherol and you want to measure tocopherol through the system, you would just have to then do the correlation.
So then I guess follow-up question for that is there a lot of time invested into setting up this correlation, a lot of samples pulled, correlating the inline? It's inline, right? The FTIR?
No, the inline FTIRs are wildly expensive. And they don't have, they have to be like in the oil flow to work, because mid-infrared has a very short path length before it loses signal.
Gotcha.
And again, it's also concentration dependent. There's a lot of papers talking about FT near infrared being used successfully to measure oil quality. And they like to extrapolate down to zero. It doesn't work. And near infrared has a quantitation limit based on sensitivity. Where mid infrared, you're measuring down single peaks in part per million, almost 100 part per million limits. So you have to understand your metric, but you can't do it. You do them offline. You can put it. Most of these new IR devices can be put in a small, environmentally controlled QC room and be run. And they take, depending on your methodology, minutes to give you an answer back.
Yep. Well, thanks for that. We have another question. Rick, which natural antioxidant do you think is most affected by heat? Our application uses a kill step, which is steam, at temps of around 180 degrees. 180 degrees.
It's a degradation. Yeah, it's kind of a combination. Tocopherol is the most thermally stable, from what I've found. Rosemary is fairly stable, but it tends to it reacts fast compared to tocopherol. It does some rapid radical closures, and you lose it pretty quickly. So a static kill step won't necessarily degrade it. It just depends how much oxygen and free radicals are going to be battling against it. Ascorbic acid, on the other hand, does degrade. It gets above 365 Fahrenheit. It starts to burn, brown, melt. So it's an interesting additive to put in a fryer.
Yep.
It's concentration dependent, though.
Okay. So Rick, we're getting a lot of questions. This is a great discussion. Another question from Steve. Do you have an antioxidant added by the oil supplier, or do you add it into the mix tank or directly to the fryer? What do you typically recommend?
It works either way. I mean, we've done a lot of pre-mix with our oil suppliers. It just depends on what's the location, the number of, how many fryers are per site we're doing, what's the country set up for doing that. I've seen it. We've actually done it both ways and had equal success.
Okay.
It's really more business driven, cost effect. How much add-on cost to have the supplier do it versus the capital investment for a dosing system.
Great. We have one question here before. I think Jill Moser had a couple of questions, but let me ask this quick question beforehand. This comes from Lori Wickland. She's asking, which natural antioxidant in fry oil have you seen extend product shelf life with the most success, and roughly what dosages are we talking about? I think that's kind of tricky because you have a bunch of different systems, but in your experience, is it a single antioxidant combination, one in particular that you think has the most efficacy?
Well, I've tested lots of antioxidants. I mean, from straight rosemary to straight green tea to blends. There isn't one particular one that outshines. It really depends on the frying system. And dose is, again, how much of it wears out in the fryer? What's your frying condition, temperature? Is it a highly oxidized fryer that's going to require higher dosing? Obviously, I'm skirting the answers because I can't tell you things that we're doing specifically, but this is how we got to these answers, by testing in controlled batch first at different temperatures, different doses, different mixes, and then adjusting the systems as we went live.
Yep.
Because until you run live, you're never absolutely sure. You just have your close.
Yep.
And then you get to the plant and you find all the things that can go wrong and what changes in the oil over real-time testing. So.
No, great answer again. This one from Jill. We have 3 related questions. What oil quality parameters are tested in continuous frying in an industrial environment? We'll start off with that one.
Well, we test the basics. We test peroxides, we test free fatty acids, we test secondary oxidation, polymer. We're actually in the places where we're using the antioxidants right now, where we're testing, we're trying to refine a method using the EPPH methodology to measure the dosing in the fryer in a kind of a rapid, takes about 15 minutes. And then we can take those samples back and compare them to total tocopherol, rosemary, OSI, all the other functions, take the product, bring it back, run it through accelerated shelf life. But yeah, there's no one measure that gives us the answer. I mean, every one of our systems has its own kind of equilibration point for what the peroxide is in the fryer, what the total, I want to say total polars. I don't use total polars because they're too generic. They don't give me detail. But the total oxidized component, total free fatty acid component, every fryer kind of reaches its own steady state. And a generation ago, when Frito Lay fixed potato chips, we found a way to make all the fryers run the same, regardless of how big they were. And that was based on being able to measure things rapidly using the infrared technology that was correlated to actual fryer oil samples, not synthesized lab samples, because you get a false read that way. You can make the calibration for oxidation, but you miss all of the background.
Yep.
So when you run it, it doesn't work.
Quick follow-up on that from my own question. Do you find that the peroxide value, even at those high temperatures, is it reliable?
No, we don't really measure peroxide in our fryers. We measure it before and after.
Okay.
In the fryer, we do have fryers that run slightly higher peroxide. They're very open-ended, like kettles.
Yep.
You can measure significant peroxide in an open-top kettle fryer. It's a continuous batch fryer, we call it, because you take a load of chips, fry it through, take it out, throw the next load in, versus a continuous fryer where we're feeding chips in at one end and 3 minutes later they've come out and there's already been another 2,000 pounds of potato slices put in behind it. So
that's interesting.
Yeah, it's it kind of goes that way sometimes.
Great. Second question from Jim Moser is, in continuous frying, does everything reach equilibrium? For example, tocopherol or other antioxidant loss and accumulation of polymerized TAGs or other measures of oil oxidation? Does everything reach?
The simple answer is yes. They just reach them at different times. I mean, the fastest reactions reach equilibrium first. And those are my oxidation reactions. The more linear free fatty acid and polymer reactions take longer to reach equilibrium, but do. And even tocopherols reach equilibrium. I mean, because you're only using so much of it before you're putting more in. So, and it's very stable.
Yeah, and her third question was actually, you already answered it. It was, do those equilibrium points occur at the same time? And she said the answer is no. It reaches equilibration at different times depending on what you're looking at.
Yeah, they all have a different kinetic. I mean, oxidation occurs fairly quickly. Hydrolysis takes a little bit more energy. Polymerization takes even more energy to recondense things. So they do happen.
Okay, I guess I have one more question, and we'll take more questions from the audience in the chat section if you'd like. We still have time. Rick, my question is there a new analytical technique? I know you mentioned the anti-par, rapid oxy. Anything that you're really excited about to measure oil quality, whether it's in the frying or elsewhere?
I mean, I'm still I'm still petitioning to get an anti-par rapid oxy. The drawback with the rapid oxy is it's a single sample at a time.
Mm-hmm.
The nice thing about it is you can get a result in under an hour for a highly stable oil.
Wow.
It does correlate very well to the OSI. But again, my limitation on the OSI is when I get I can get to 130 and keep a pretty good relative answer. But when I go to 140, my numbers just become noise. The anti-par runs at 140 at pure oxygen, and we're talking, significant differences at 5 minutes that are reproducible between oils.
Wow. Yeah, that's a lot faster turnaround. Yeah. Oh, we got a couple more questions that just came in. We have a question from Cindy Tien. Do you find antioxidant residue in your potato chips or any kind of thing that you fry, considering that the chips or the end product absorbs a good amount of oil?
Sure. If it doesn't carry over into the chip, it's not going to extend the shelf life of the chip. Tocopherol is the best one that carries over because it's got the most stability. But there are trace amounts of the other antioxidants. Even we have a system that runs a mix with TBHQ. There's TBHQ in the finished product. It doesn't burn out of the fryer like has been described in batch systems because, like I said, we're feeding it in continuously. So it does reach an equilibrium, and it is measurable in the finished product.
Wow, that's really interesting. Jennifer's son has another question. Can you assume that the degree of oxidation of a multi-component system is the same for different components? Can I pick one component as a marker in LCMS testing? For example, using the ratio of saturated to unsaturated bonds in LCMS?
That's two separate questions. The first question is the components. No, unless you put a mark, depends on what you're trying to measure. If you're trying to measure what your dosing was, yes, you can track that pretty consistently with especially with tocopherol in most cases. But the other components will break down into different levels of steady state and not be equivalent to the starting ratios that they went in at. The second question about the saturated unsaturated ratio, I've never used that for any of my testing. Again, our products reach a steady state. I compare the oil profile to the fresh oil. It's not significantly different enough for me to use that as a measure. Again, my frying systems are different. My more oxidized frying systems, I do see a bit more of a change in the total fatty acid profile from the fresh to the fryer, but it's not anything we've ever leveraged, mainly because at our plant level, we got no way to measure it.
Great. Well, thanks for all the questions, everyone. Really good questions, really great conversation, and thanks again for Rick for coming on and spending his time with us. We do have a little bit more time if anyone has a last-minute question that they're burning to ask, and if not, we'll wrap things up.
Well, I appreciate the opportunity to voice what may just be my personal opinion on antioxidant testing and development of systems. But I know that the one thing that it does is spark that thinking process, ideas. What can we do next? How do we do it better? Really, what I'm pushing for is papers for next May. I'm co-chairing with Matt Flannery. Am I saying his last name right? Anyway, we're looking for papers on in the lipid oxidation section. So I kind of want to make a push. There's time to do some of this research in get some cross correlation with it. I'm doing some cross correlation work as well. Stuff I can't publish, obviously, but
Mm-hmm.
it can be, some of it can be published in a generic way from our partners.
Great. Again, thanks a lot, Rick, for coming on. And I think we'll wrap up the session with that. I think it was definitely successful, and we enjoyed listening to you talk about antioxidants, in particular antioxidants and frying.
Well, thank you, David. Appreciate it. Thank you, AOCS team.
Yeah, thanks a lot, AOCS.
And Cindy as well. And Nora.
Right. Thank you, everyone, and thank you to both Rick and David for their time today. And that concludes another Webinar Wednesday, and we'll see you all soon.
Bye-bye.